Hi, this is Dr. Lovett with Deltas Performance. In this video, we're going to be talking about how the virus gets from in the environment to into your body. We need to know about this because it helps us understand all the different places to look for damage that the virus can cause and helps us understand why you may have symptoms if you do. First thing we want to do is we want to draw the brain. That's your brain. Top part is the brain, the cerebrum. The stalk hanging down is your brainstem, and the back is the cerebellum. There are two major ways in which viral particles can get into your body. And specifically with COVID, there's the nerve route through the peripheral nerve and the blood route through your lungs. So let's draw a face and cranial vault around the brain. So that's the nose. Air is going to come into the nose or into the mouth. If it goes to the nose, it's going to go through the nasal concha, down through the back of the throat, and into the lungs, right? So the first way, the nerve root is going to come in and it's going to attach and connect to the nerve that allows you to smell. That first cranial nerve goes into the temporal lobe here, goes into the frontal lobe here, and it goes into the lower brainstem here. If the viral particle gets into your nose, then it can go into any of those areas and cause inflammation directly where it gets in as it travels throughout the body. Now, for the rest of the air that makes it past the nose, it's going to go into the lung. Let's draw a little zoom in section over here. So in your lung, you have these things called alveoli, which look like little stalks and bubbles. To give it larger surface areas, you can get more oxygen in and more carbon dioxide out. Now, the virus can use the same mechanism through water vapor and aerosols getting into your body, and it's going to travel in over here and get into the bloodstream. So once it's in your blood, it can travel anywhere in the body that the blood goes to. So let's look at where the blood reaches the brain. So we have something called a blood-brain barrier. What is that barrier? The barrier is just cells. The same thing as the blood vessels, just cells. So if you have a blood vessel that is traveling around the brain and supplying nutrients to the brain, you have cells. So if we're looking from this direction, you have cells that actually make up the wall of the blood vessel. It's not just tissue. You also have cells that cover the blood vessels, and these are known as astrocytes. It's an immune cell that maintains the integrity of the barrier between your blood vessels and the blood and your brain tissue. Normally, you have very tight gaps between these two cells, between cells of astrocytes, which prevents things from getting into the blood vessel. However, as cells get inflamed, and remember, the virus can get into the cells that make the blood vessel, it can get into the cells that make the blood-brain barrier, and then it can get into the tissue that is actually the brain, the neurons, and can cause inflammation there. So the idea is, as these astrocytes get more swollen, gaps start to form. So think about it like this. If you have some smaller cells and smaller holes, then the size of the gaps is going to be very small. But if you have larger cells, because they're now inflamed, the size of the gaps is going to be much bigger and allow more things to get through. Opportunistic viruses, bacteria, your own immune system that can cause autoimmunity. They can cause a lot of damage and that can cause a lot of symptoms. So what we want to do is understand that we've got a couple different places that we have to look for. We have to look for, A, is the peripheral nerve working well? We have to look and say, are the different parts of the brain that the virus can get to? Now, here's the thing. All the research is showing once the virus gets to the brain, your immune system fights it off well. It gets rid of the viral particles. The problem is the overwhelming response of the immune system in order to kill the viral particles also creates some collateral damage in the area around it. And that collateral damage can create symptoms. For example, this area, bottom of the brainstem, controls something called your autonomics. You may know of the autonomics as your sympathetic versus your parasympathetic systems. Those two systems make up the autonomic system. Sympathetic is flight or fight. Parasympathetic is typically known as rest and digest. The goal is for your body to have things very tightly maintained. So that way you don't get too far in one direction or the other and it doesn't rubber band snap back. What will end up happening is as this regulatory center starts getting more and more inflammation, you can get more sympathetic and more parasympathetic and have symptoms when you get into those sections where you're too far in one direction or another. That's why taking care of reducing inflammation is a really big part of recovering from these chronic low-level neuroinflammatory virus-related infections. This also is the same exact thing that happens in concussions. It also means that long COVID syndrome is classified as a non-traumatic acquired brain injury. And treating it as such is a good way to recover, and we'll cover how to treat it and how to improve it in the next video.